Assalamu alaikum dear students. This is our next problem. Problem having been once again chosen from the book Modern Physics by Kenneth S. Crane. Okay. Modern Physics by Kenneth S. Crane. As usual, we first come towards its statement. Okay. Dear students, this problem has three parts. Part A. What is the wavelength of an X-ray photon of energy 10.0 kilo electron volt? Part B is quite similar to part A. Okay. Part B. What is the wavelength of a gamma ray photon of energy 1.00 million electron volt? Okay. Dear students, here we can see that statement of part A and part B is so similar that we can imagine the answer or solution to this problem. We can estimate of which nature this answer may be. Dear students, we can see that energy in part A is 10 kilo electron volt, that is 10,000 electron volt, while in part B this energy is 1 million electron volt, that is 10 to power 6. Okay, in part A 10 to power 4 electron volt, while in part B 10 to power 6 electron volt. Okay, so we can estimate or anticipate that answers of part A and part B will differ by a multiple of 10 raised to the power 2. Okay, because in part A energy is 10 to power 4 electron volt. Okay, because 10,000 can be written as 10 to power 4. Okay, 10,000 electron volt or 10 to power 4 electron volt is same thing. Similarly, 10 to power 6 electron volt or 1 million electron volt is same thing. Okay, however, part C is that what is the range of energies of photons of visible light with wavelengths 350 and 700 nanometer. Here wavelengths are given and we have to calculate energies. Okay, we will assume E1 E2 for we may denote we can denote these two energies as E1 and E2, and we can denote these wavelengths as lambda 1 and lambda 2. Okay, and hence in this way we will find the values of E1 and E2, and then we will say that their range is from this to this. Okay, that is first from lower energy to higher energy. This will be the range. Okay, so dear students, here nano means 10 raised to the power 9. Okay, we know. Now we come towards the helping tools. Okay, as usual in other. Okay, this is the first helping tool. This is a table. Okay, dear students, in this table speed of light is also given. Moreover, Planck's constant h is also given, and this is given in two shapes. Okay, that is Planck's constant h is also given in terms of joule second, and it is also given in terms of electron volt second. Okay, here we will use the value in terms of electron volt second. Okay, we will take this value and we will not take this value. Okay, we will take second value. Okay, similarly, dear students, here the value of HC together is also given, but in the presence of separate values of H and C, we do not need this value which is uh, given collectively for our convenience. Okay, no doubt convenience has been made for us in this table, but it is a matter of discretion for us whether we utilize this facility or not. Okay, so we decide that in the presence of two values of H and C, we do not need to take the value of HC which is given collectively. Okay, dear students, this is the next tool likely to be used or utilized in this problem, and this tool is only about prefixes that is from 10 raised to the power minus 3 or plus 3 to 10 raised to the power minus 24 or plus 24. Okay, with the difference of multiples of 1000 or division of 1000. Okay, here nano 10 raised to the power minus 9, its symbol is n. Okay, now we move to third tool, which is a definition of momentum of a photon. Momentum of a photon P is equal to E over C, where E is the photon energy and C is the speed of light in vacuum. This alternatively becomes equal to HF over C, where H is Planck's constant and C is again speed of light in vacuum. This becomes alternatively equal to H over lambda, where lambda is the wavelength. Okay, F is the frequency and lambda is the wavelength. Or that is to say, tool number 3 has been once again shown or introduced in a slightly different mode. This snapshot has been taken from some other book. However, it also conveys the same philosophy as first part of this tool, that is tool number 3. Okay, in this second alternate tool, it is written that or E is equal to HF equal to HC over lambda, Einstein equation for photon energy. Okay, nothing different from above. The only difference is that this snapshot has been selected from some other book. Okay, now we come towards the solution. First we come towards part A. Okay, for solving part A, we adopt the strategy or methodology that we know that E equal to HF, E is equal to HF is alternatively equal to HC over lambda. Okay, this implies that if we take lambda on one side, then on other side of equation we will get HC over E. Okay, dear students, as I have already mentioned that in a tool which was consisting of a table in which value of Planck's constant H was given in two different systems of units, and also the value of HC in a combined manner was also given. Okay, from that table we take the value of H. Okay, we noticed that value of H was given in two shapes. Okay, so we have taken here one of those two shapes, which is in the form of electron volt dot second. Okay, so value in place of we have to find wavelength lambda, which is equal to HC over E. Okay, here E is given in the statement. Okay, which is 10 kilo electron volt, which will be equal to 10,000 electron volt or 10 raised to the power 4 electron volt. Okay, and value of H is taken from the table, which is shown as a tool in this problem or video. Okay, Moreover, value of C is also given in the same table, 2.998 into 10 raised to the power 8 meter per second. Okay. So what we have done, we have simply put these three values in this equation. Okay, nothing extraordinary. Okay. So dear students, here second will be cancelled out with second. Moreover, electron volt will be cancelled out with electron volt. Okay. In the next step, in place of 10.0 kilo electron volt, we have written it as 10,000 electron volt. Okay. And when we multiply 4.136 with 2.998, then we get the result 12.14. Okay. So 12.40, 12.40. Okay, dear students, actually 12.40 is not appropriate. After decimal, each digit is separately spoken or pronounced. Okay, so 12.40 inappropriate, 12.40 appropriate. Okay, 12.40 into 10 raised to the power minus 7. How minus 7? Because 10 raised to the power 8. Here 8 is plus, while 10 raised to the power minus 15. Here 15 is minus. So minus 7 will remain in the numerator. And in the denominator, we have converted 10.0 kilo electron volt into electron volt. Okay, by taking 1000 in place of k. Okay, so this will become equal to 12.40 into 10 raised to the power minus 11 meter. Okay, because electron volt will be cancelled out with electron volt, and 10 raised to the power 4, which is in the denominator, when it will be shifted to the numerator, it will become minus. So minus 7 and minus 4 will be added, and they will contribute minus 11. Okay, so to the extent of 12.40 into 10 raised to the power minus 11 meter, our solution, our answer is quite okay, quite acceptable, but this is slightly less appropriate, because I have already mentioned many times that for us 10 to power minus 11 is not very important. What is important for us is 10 raised to the power minus 9 or 10 raised to the power minus 12. Okay, because when we convert it in minus into 10 raised to the power minus 9, we will call it nano. When we convert it in 10 raised to the power minus 12, we will call it pico. So okay, so it is our discretion whether we convert this value in terms of nano or pico. Okay, so in the next step, we have taken in place of 12.40, we have made it 1.240 into 10 raised to the power minus 10. Okay, okay, because we have shifted decimal one places behind, so minus power has been reduced by 1. Okay, in the next step, we have shifted decimal further one step behind, and hence 10 raised to the power minus 10 is again reduced by one step. Okay, so it has become equal to 0.124 into 10 to power minus 9 meter, and this is equal to 0.124 nanometer. Okay, it could also be converted into picometer, but I think it is quite okay. Now we come towards part B. Part B, there is nothing new in part B. Okay, exactly 100% the same procedure has been repeated. The only difference is that here value of E, which in previous part was 1 was 10 kilo electron volt, that is 10,000 electron volt. Here it is 1 million electron volt, that is 10 raised to the power 6 electron volt. Okay, so we do not go in detail of these calculations, and we reach this point that it becomes equal to 12.40 into 10 raised to the power minus 13 meter. Dear students, as I have already mentioned that 10 raised to the power minus 13 is not priority wise appropriate for us. Priority wise, what is important or appropriate for us is 10 raised to the power minus 12. 10 raised to the power minus 12 or 10 raised to the power minus 15 or 10 raised to the power minus 9. So we write it in the form, in place of 12.40 we write it as 1.240 into 10 raised to the power minus 12 meter, because we have shifted decimal one step behind, so negative power has been reduced by 1. Okay, so and the 10 raised to the power minus 12, we know that 10 raised to the power minus 12 is equal to pico, and in the last step it is written as equal to 1.24 picometer. Okay, however, we have made some conversions irregularly. Okay, but whether we make conversions regularly or irregularly, it is less important. Okay, it is just a matter of discretion for us. Okay, to this extent 12.40 into 10 raised to the power minus 13 meter, our problem has been solved absolutely. And further steps are just being done as a formality, as a cosmetic arrangement. Okay, so when 1.240 is converted into 0.124, then 10 raised to the power minus 12 will be converted into 10 raised to the power minus 11. Okay, moreover, when it is when decimal is shifted again one step further behind, then 10 raised to the power minus 11 has been shifted to 10 raised to the power minus 12. Okay, 0.0124 into 10 raised to the power minus 10, and if decimal is shifted one step more behind, then it will become 10 raised to the power minus 9. Okay, so this becomes equal to 0.00124 into 10 to power minus 9 meter, and we know that 10 to power minus 9 is nano. So our answer has become 0.00124 nanometer, and this can again be written as 1.24 into 10 to power minus 3 nanometer. Okay, and this is again equal to 1.24 picometer. Okay, because 10 to power minus 3 and nano is 10 to power minus 9. Minus 9 and minus 3 will become minus 12, and minus 12 is equal to pico. Pico is denoted by P. Okay, and hence our part B has been solved successfully. Now we come towards part C. Okay, here situation is different. Here we have to find out energies while wavelengths are given. Okay, so we have given two wavelengths are given. We have given them names lambda 1 and lambda 2. Okay, and according to lambda 1 and lambda 2 we will find their respective energies in terms of E1 and E2. Okay, two wavelengths were given which we have denoted by lambda 1 and lambda 2, and accordingly two energies E1 and E2 will be obtained from these two wavelengths. Okay, so let E1 be the energy of photon with wavelength lambda 1 equal to 350 nanometer. Similarly, let E2 be the energy of photon with wavelength lambda 2 equal to 700 nanometer. Now, E1 is equal to Hc over lambda 1 is equal to 12.4 into 10 raised to the power minus 7 electron volt dot meter over 350 into 10 raised to the power minus 9 meter. Okay, in place of nanometer, nano we have used 10 raised to the power minus 9. Moreover, the term Hc has already been calculated, and even if not calculated, it is given in the table in this consolidated form. Okay, we can also take this from that place, while we have already calculated it in part A and part B. Okay, so E1 has become equal to this over this, and alternatively E1 has become equal to 3.5 electron volt. Okay, because dear students, in Hc units are electron volt dot meter, while wavelength is given in nanometer, which has been converted into meter by using 10 raised to the power 9 minus 9 in place of n, and hence meter will be cancelled out with meter, and our result will be E1 equal to 3.5 electron volt. Similarly, E2 is equal to Hc over lambda 2 equal to 12.4 into 10 raised to the power minus 7 electron volt dot meter over 700 into 10 raised to the power minus 9 meter, and in this way energy E2 becomes equal to 1.77 electron volt. Okay, hence range is from smaller wavelength, smaller energy to higher energy. Okay, here E2, that is second energy, is smaller and first energy is greater, so our range will be in between smaller and greater energy. Okay, hence range is from 1.77 electron volt to 3.5 electron volt. And this is the end of our problem, our video. Till next video.